Hey there, and welcome to another channel video that today will be dedicated to the just released Tooltop ET13S thermal camera and multimeter. It has more resolution, more counts, and some new functions, and I will show you all in a bit, with also a teardown, so bear with me. As before, this thermal camera was sent by Tooltop free of charge for this review, and I didn't receive any payment from Tooltop to produce this video, and they didn't have access to it before it was published on YouTube. But Tooltop was kind enough to send these items, so let me thank them. And also you, my viewer that sponsored this channel by using the affiliate links on the screen or in the video description for doing your purchases on AliExpress or Amazon. You pay exactly the same, not a cent more, but you are helping me with the channel and keep these videos coming. Every cent I made on affiliate commissions is spent on the channel to improve these videos and show you new equipment or projects. So thank you for your support. Enough thanks for one day. Now let me show you the key features. So the ET13S is delivered in this box. It has only one marking here and also here. No reference to the brand. So let's open it. Okay, we start by having a user manual. It's in English, this one, and you have all the characteristics here in the bottom. Okay. Also the same user manual in Chinese, the charging cable, USB Type-C, a set of leads, because this is also a multimeter. So those are Cat-C 1000 volts. I don't know if it's possible to see in the screen, but yeah. And let's see. Yeah, pointy enough with these little caps for protection. In terms of the wire is, yeah, it's flexible, not silicone, but very flexible. Yeah. Okay, and then we have the ET13S. Let me start by taking the film off. Okay, just for a reference, let me show you what it came in the previous one. We had this user manual. It's much more confused. Chinese from one side, English from the other. But it's more or less the same that you come here. The same test leads, and also the device is pretty familiar. In terms of difference between the devices, the shell is absolutely the same. It's the same, no difference at all. We have the test leads here in the bottom in both of them. In the back, we have the screw to access the battery, and then the camera on the top. Nothing in the top, so that's basically the same case. On the front, we still have the 4 buttons with the same engraving, same letters in it. But if you notice below the buttons, here we have a few more icons, and also it says that now it's a true RMS multimeter. So new to this device, it seems that we now have frequency, temperature, also live wire, and NCV. Capacitance, diodes, and resistance testing were in this one already. Continuity also, and voltage AC and DC. We have a lot more functions in this one. And if you notice here at the top, it says NCV. Let's start this and compare in terms of menus what we have more. I have here both devices side by side. One thing that seems to be more evident is that this screen is much darker than this. Maybe because this one is without protection for more time, but it kind of notice this screen to be much darker in terms of display. Let's power both. Okay. This takes a bit longer to put up as a counter. A little more, yeah. And also in terms of screen, I should say that this seems a bit better, yeah. The color seems to be more accurate. Okay, let's start. In terms of menus, you have those menus on the top. Picture menu to take picture is here on the top, and also the properties menu. In terms of the scale, I don't remember if this is activated or not. I think so, but we don't have it here right now. We have the time and date now here, and the auto that was not in this available in this one. Let's see in terms of menus. Both are with touch screen. So let's start with the menus. Let's enter this system. We have basically almost the same functions. This function define if you want to start in infrared camera or multimeter, the automatic shutdown time, and also you have the language. It seems that now you have also in the ET13S the Deutsch, and we can set up the time. Yeah, it's a bit off, but I will not do that. Okay, it has the time now. Let's go back. In terms of backlight and sound, it's exactly the same. So you have here the brightness control and also the time for the screen enter safe mode. Sound on or off, nothing much. Infrared camera. In infrared camera, you can see immediately that we have now a few more color tables or palettes. You still have the Celsius or Fahrenheit degrees, and also you have the emissivity control in here. In the bottom, we have the update auto speed high or low, and in this one, you have the temperature level auto high or low. Okay, so going back, entering the multimeter, we can also see that right now we have a few more options. In this one, we didn't have the NCV, as I told you before, neither the temp, and also the auto. So it seems that now we have a smart multimeter here with the auto function. I will test this in a few minutes. Okay, going back. And in terms of storage, okay, we still have the same interface. It seems that no difference in here. And the USB mod. Something that I should tell you is the first thing that I did when I received this is connect this to my PC to see if I can download the image. And right now I can. And I also have some news that right now this device, the ET13S, can connect to your PC and has a software to analyze the pictures you take. But I will show you that ahead in a video. Okay, this one I tested recently. I cannot make him appear on my PC. Maybe it needs a firmware upgrade, I don't know. Going back, the about. In the about, we now have, other than the version, the firmware version, also a software version. And finally, you can see that this one was 90 by 120. This is 192 by 192, so much bigger resolution in terms of infrared observation. Okay, that's it in terms of menus. Going back to the main screen, we still have the capture screen. Yeah, takes about the same. No, this is takes a bit longer, but yeah, about the same. Let's now see the multimeter functions. Okay, the multimeter screen is a bit different. As you can see, this one is in auto mode automatically. And we have this one starting as voltage DC. On the screen, you have the other options, the new one, NCV, and also the temperature. All the rest is the same. So this line is totally new. To get out of the auto mode, you just press here on VC, voltage DC. As you can see, you have a few more informations on the screen, like the temperature, that it's not present in this one. The DC passes from the top to bottom and the auto goes to the top. We start in millivolts in this one and in volts in this one. And in terms of Stability, it seems much more stable. It's at 0 volts. Let's try again the voltage AC. In terms of voltage AC, we have also here now the frequency of the signal, and all the rest is the same. We have the resistance, again the temperature always present, diode measuring. We have capacitance, seems the same, also detecting here some capacitance, and continuity. Yeah, and they put the temperature in every screen. So in terms of temperature, it says 28. This should be, I believe, the temperature it detects on the room. And I don't think, or the temperature inside the device. So I don't believe right now that the room it's 28 degrees. So I went to grab my air quality detector, and what it says is that on the room we have a temperature of 21, 22 degrees. So this should be the temperature of the device, not of the room, I believe. While I was, going around this testing, both devices entered in screen save mode. When that happens, the power button starts to glow, as you can see. And you just need to press anything to have again, and then the power button goes back to off state. Okay, continuing in this multimeter section, we have the temperature and the NCV. We will test this in a few moments. I don't see here the live wire. Probably we will have to have it connected here and it will use the NCV, but I believe that it says here that we have live wire function, so I want to see how that works also. Okay, continuing with the multimeter section, let's go to the graph. We have this graph in both devices. Right now it's not running. We can press start. Well, I don't have anything to connect it. It seems that it will not start. We have also the configuration. It's the same in both, with the sampling period, the continuous sampling, and that's about it. We can go back to the graph. And finally, we have access also to the menus. One thing that is common in both also, it's that the storage it gives you the percentage of used storage, or free storage. That's more like it. I have my DC voltage calibrator ready for the testing. So let's not waste any more time and start. 1 volt. So it gives you 1.001. Well, when compared with the Siglent 4 digits off, let's continue. 2 volts, 3 volts, 4 volts, 5 volts, 6 volts, 7 volts, 8 volts, and, well, this is 18 digits off. I had the idea that the previous one was much more precise. So back to 0. With, 9 volts, and back to 0. Let's try in millivolts section what he gives. So starting with 100 millivolts. Okay. 200. 300. Much more precise. 400. 500. 600. 700. 800. 900. And back to 0. In terms of voltage, probably the difference is between the error margin, but just to compare with other devices. Okay, going back to 10 millivolts. 10 millivolts. Yeah, it's there. 20. 30. It takes a while, but it gets there. 40. 50. 60. 70. 80, 90, and back to 0. Let me try something. In auto, if it selects millivoltage range, yes it does, more or less. So this should be, it's detecting resistance instead of voltage, millivoltage. So that's a bug. Yeah, it's detecting resistance and not millivoltage. Okay, let's see if it does the same here. Yes, it does. So that's not good. Yeah, in 800 millivolts it detects voltage, but we lost the millivolts range. Right now we just have the normal volts, and we had the millivolts range in this ET12. Okay, so we were in 10 millivolts, very quick, 10, 20, 30. I think I've done this already, so let's move on to the 1 millivolt. Okay, so 1 millivolt it's not detected. 2 millivolts is not detected. What is 2 millivolts? No. No, yes. Let's give him time, but no. 3 millivolts, it detects 2, 4, 5, 6, 7, 8, 9, and 10. Okay, that's it in terms of DC voltage detection. I will not go further to microvolts because it will not be able to detect it. So let's move on. To test the AC voltage, I have here my Siglent already testing the voltage with the probes directly connected to it. Let's insert the probes of the ET13S and see what we get. Okay, we have more or less the same voltage. Let me take this out of the way. Yeah, that's better like this. I think that we are okay. It's giving basically the same voltage. As you can see, I have here voltage between 234 to 35. It's oscillating a bit, but it's more or less the same value in both devices. So I think we are good. Now I will detect the live wire function. Let's see what we get if we connect here the test leads. Well, we don't detect anything because it doesn't have power. Let's see on the other one. Okay, it's detecting, I don't know exactly what, AC 6.47, 50 Hertz. I don't know what is detecting. Let's put this in NCV. Okay, let's try again. No, NCV. Okay. Now it detects. Okay. The other one, I don't know why it's beeping. It's the neutral, but okay, it's not beeping at full speed like the other one. Let's see again here. Yeah, quite loud, and it detects the live wire. Well, if you have it in auto, it will detect something like 6.49. It makes a bit sense since I don't have the neutral connected, but even so. I have the ET13S already on NCV, so let's test the NCV function. Okay. If you bring it really, really close to the wire, yeah, it seems to work. Let's see again. Okay. In here doesn't detect. The power is from this side. Yeah, kind of detects but you have to be very near the source. Even so, I've seen worse this last week. Yeah, let's see. Well, it works. I've seen worse than this, much worse. Yeah, it seems to work. Okay, let's move on. I will now test the resistance measurement with this device. I have here my precision resistor reference board, 0.1%, 25 parts per million resistors. So let's start with auto. When you test with auto, it will give you always this annoying beep, but the value is correct. So I will put this in, resistance. The value for reference is 10 ohms, and the value we get is 10.2. Okay. Now we have 100.03 ohms, 100.0607 ohms. Okay. We have now 1K, 1.0003K. So let's test it. 1.002. Not bad. Next, we have 9.995K. So yeah, that's okay. 9.95. And for last, we have 100.06K kiloohms. Okay, let's see what we get. So we get 100K in terms of resistance. Using the same board, I have here already some capacitors. Let's start with the first one. It's 102 picofarads. Let's see. Okay. So 170. Okay. Next, we have 1.02 nanofarads. 1.05. Close. Next, we have 10.4 nanofarads. Okay, spot on. And we have next 98.7 nanofarads. I believe that's a 7. Okay, 100.1. A few digits over. That's okay. This one always gives me a different value by 50 nanofarads off. So it's 929 nanofarads, and it's giving me 862, more than 15 nanofarads. Okay. And the last one, it's 10 nanofarads, gives also always like 30 nanofarads off. Let's see. 10.31. So it's just what I told you, 30 nanofarads off of the value sign on the board. So it's okay. So now I will test the continuity. Let's see first how fast it is to beep. Okay, it seems fast. And the time to update the screen is about 1 second, maybe not so much. Yeah. So it seems good, it seems okay. I hope that you can hear the beeps. Seems very well in terms of continuity and time to update. I will now test some diodes. I have the usual gang reunited here on my workbench. Let's start with this one. This should give a gain about 595 to 600. So we have 611. Shouldn't give any value in a reverse. Yep. Let me try again from the front. 611. Okay. These ones should give something like 1.7 volts. Yeah. And the other one also 1.7 volts. This one is 2.6, I believe, or 7, something also like that. Yeah, the LEDs illuminates with a lot of light. Seems okay. To test the temperature reading feature of the multimeter, I will use the hot air part of my rework station, the WEP 853D. It has also iron and a power supply. What I will do now is set this at 250 degrees. Let's power this up. It's already set. And let's wait while it heats up. Okay, almost there. 250 degrees. Let me power my Siglent, because after I will check also on my Siglent what is the voltage that we have. Okay, I think that we have this set now. Let's start testing. Putting the probe in the output of the hot air. Oops, let me take this out of the way, sorry. We are getting a temperature of 230, 40, 50, 52, 55, 60. Well, it was touching the metal, so yeah, 50, around the 250 something. To make sure that this is correct, let me take the probes out and connect to my Siglent. Okay, temperature, and let's see what the Siglent says about it. Okay, we are getting there. 230, 40. I have to make sure that I'm pointing to the right place. 257, 56. Yeah, it's oscillating a bit. So right now, I think I got it. It's around 270, 60, 70. Yeah, it's 25 degrees over. Ooh, even more. It's outputting 200 and between 250 and 270. 80, 90. Whoa, this is way over. Let's see if it is from my equipment or from the multimeter. Going back again for the ET13S. Okay, it's going up. I think it's my rework station that is giving a lot more heat than it should. So I think I should worry about my temperature 300. So the problem is not with Siglent or with the ET13S. The problem is really with the temperature control on this rework station. I should think in buying a new one as fast as I can. Okay, but in terms of the readings, I think that we are okay. It seems to give more or less the same readings in both devices. Now let's see how is the recording or the image capture in several situations. I will start with that. Let me see if I can show you like this. This is my rework station, also a power supply with soldering iron, but is currently turned off. Well, compare with my hand, you see the difference, but it detects the hottest zone in there. Let's move to, for example, my Siglent. That one on the top is my DC calibrator, and below is the Siglent. I should have, let me see if I can show you. On the top, the bright one is a small computer that I have here. In terms of speed, let me show you. He updates quite fast. It's quite fast to update. You see also all the levels of temperature in my hand. Something that I would like to test is how will this compare to the P2 Pro that is using a mobile phone, but with the P2 Pro without having the macro lens. So it will be basically the same solution we have in here. What I will do now is passing to see how is the detail of one and the other. Don't forget, this screen is much better and all the capabilities of this is much better because it's a smartphone. But let's see what is the difference in terms of identification of components and stuff like that. So this is the P2 Pro analyzing the board. If we go a little further, we can have better detail, as you can see. And yeah, that's it. We can even see there the reflection of the camera. Okay, and now we have the ET13S. So without the camera, obviously this has more resolution, almost the double, but without the macro lens, what we get is almost the same. Not the same because we have a much bigger, obviously this is a better product, we have a much bigger image and more resolution, but without the macro lens, the result is more or less about the same. This is the macro lens from the InfiRay camera. And if I use this lens in here, and this device does not have a lens provided by default, let me see if I can show you. Yeah, like this. You can see everything, even the tracks or the pins of the SMD processor. Whoops. Let me put it in place again. Yeah, you can see everything and the components with much more resolution and detail. So the problem in terms of resolution is not the equipment. I will recommend for Tooltop to have an optional lens for this device because it really works to have one in here. Look the difference. You have all the components in there and you can see what is heating up and what is not. Much better. It's not like you cannot do the work like this, but for small devices like this one, we should really have a macro lens available. Something that will fit there, I don't know. Okay, so what I will do now is connect this cable that is connected to USB port on my PC. And I previously took or saved some images from several situations. As you can see, when we connect the cable, it starts charging, and while charging, this red light appears. It will disappear when the battery is totally charged. But continuing on the connection to the PC, let's go here to USB mod. Okay, and as you can see already in the screen, I have a new drive called Thermal D, like this one. And on that drive, I have several images. I will select all of them and copy to pictures. Yeah. Well, I have here the pictures already. So now I will pass to my other computer. I have here the software, but it doesn't seem to be able to load the photos in this computer. I don't know why. So you have now on the screen my editing PC. I have the image copied to here. So now let's open the client. I have here the IRDMM. Okay, here it is. Let's take this out of the way so it will be more clear. And open an image. Let's select this hand. As you can see, where you click, it will give you the temperature click on the temperature in this point of what you had. This is a little weird because you can click outside the area, but yeah, this will give you the temperature. It's quite limited, really quite limited. You have the coordinates of the temperature. For example, we can have the temperature of the arrow, and that's weird stuff, or in this arrow also. So it's quite limited, but gives you an idea, and if you want to work with it, you can. Let's open another. This is the DC calibrator, yeah, or the PC. Yeah, this is my small PC that I have in the workbench. In terms of options, that's all you can do, but at least you can download the image. Now is teardown time. Okay, so we have here the board. It has a screw to connect these two holders. The screen doesn't have any special protection. It's not glued. And we have here a couple of components. Let me put this under the microscope so we can see it all. I have the board already here in the microscope. Let's start with this signal relay. This is a miniature signal relay from Axicom. We have here this big one. It's kind of, let me just focus so you can see. It's kind of a block in here. This block doesn't have the letters on the top, but on the bottom we can see that is a ET13S. It's a plastic encapsulated transistor. So a bit ahead, we have here two ICs. Let me see if I can read what is in here. Okay, so we have this EL357N, and this is a photoresistor. And on the side, we have this little one. Let's see how this reads. It's on the opposite. And this guy here is a dual channel digital isolator. To be more correct, it's a 150 kilobits dual channel digital isolator. This is from 2Pi Semi. Okay, and we have another scratch IC here. This has all the aspect to be the main processor of the device. Just on the right side of it, we have two 8-bit bidirectional voltage translators, those two. Some connectors here, and also the connector for the IR camera. Okay, so we have here on the reverse a 64 megabit serial flash memory from Winbound. And I cannot read this one. This is the XPT. Okay, this is the XPT2046. This is the display controller or the screen controller. And what else do we have here? Let me see. Okay, we have a voltage regulator here, the 1117 also. And I think that we are about it. This is another voltage regulator. Okay, this is the bottom, and I think that's it. Let's wrap this up, and today I'm going to start with the improvements. As a multimeter, it now has 10,000 counts, and that is a huge improvement of the previous 4,000 on the ET13S. It also has new functions like the auto, NCV and live wire, but to be honest, the auto left me a bit disappointed. Some measurements like the millivolts should be immediately identified, and it seems to fail on that. Forgetting the auto, when measuring it worked well. Not the most precise that I had in the workbench, but it was within the error margins. The new live wire function works pretty well, and the NCV works also. Another cool thing is that you finally are able to download your image and with a very limited application analyze them on the PC. Regarding the thermal camera, it is noticeable the better resolution and refresh rate. The 192 by 192 pixels resolution is a welcome improvement from the 90 by 120 on the ET13S. Also to note that we now have an auto mode in thermal camera that switch automatically from low or high color levels. Another point to mention is the new palettes available, from the previous 2 on the ET13S to 5 on the ET13S. Now the price, and starting with my mantra that you pay what you get. If you get more, you will have to pay more, at least for now, but I believe this device will have a lower cost in a couple of weeks. It is listed on Tooltop AliExpress store for 143 euros or around $154, and that is almost the double of the ET13S. Fact that I'm not sure if it will not be a deal killer. When you have also from Tooltop the ET692C with 256 by 192 pixels of thermal resolution at 25 MHz refresh rate for 187 euros or around $201. So for 40 euros or 50 bucks more, you will have a professional equipment with a much better resolution. I'm not saying that this is a bad product, not at all. It is a huge improvement from the previous one, but for me, the sweet spot will be around 110 euros or $118 for this kind of equipment. But this is just my opinion. If you think that this device will be a good solution for you and you want to help the channel, you can use the affiliate links on the screen or in the video description to sponsor the channel when purchasing on AliExpress or Amazon. Same price to you, a big help to the channel. As always, if this video was useful to you, please share your love and slap that like button. If you are not subscribed, you might be missing a lot of cool reviews of devices I receive each week, most of them new in the market. That's it for today. Thank you for watching and spending this time with me. I hope that you can also join me in my next video. Bye now, until then.